So, hello everyone, again, welcome again to another Saturday live stream. MicrobHunter here. Today I would like to show you a couple of my hand microtomes that I have, and I'd like to discuss a little bit some of the advantages and disadvantages that some of those microtome models have. I'm just checking again if everything works here. Yes, I think I am online right now. Would like to send greetings all around the world. First of all, I see that some people have already started posting. I hope that the sound also works. Please do give me a short feedback. I have to tell you that I was a little bit shocked a few days ago because I did another private microscopy live stream for a few students, and then all of a sudden the sound completely stopped. And I still haven't found out why this is the case. So if there's a technical problem, like that the live stream stops or the sound stops, then I might have to restart the live stream. This happened a few weeks ago as well. All of a sudden everything closed down automatically. I don't know why. And then I basically had to restart it using a different link. So if something like this happens this time again, then just be patient and check if I'm starting the live stream again. Okay. Yeah, I see that many people are saying hello around the world. Hello back. If you have any specific questions that you would like to ask me, please do ask it in the chat, but I'll make an @MicroBehunter or @Oliver there so that I essentially know that I can answer those questions. Otherwise there's too much to read and then it's a little bit too difficult. Okay, so so this is the thing, and today I would like to simply show you a couple of things here what I've got, especially those microtomes, and later on I would like to do the following. I would like to also put this here under the microscope. I'm just gonna show you what I got here. It's still packaged originally. This is what one of my colleagues, I'm a teacher in school, and she visited over the summer holidays. She visited Norway and brought along some Nordic elk jerky. So these are kind of the elks. These are those big animals with those big, how do you call them, antlers? Yeah. So basically the moose, I think they're called in North America, and it's dried meat with a little bit of salt. You can actually see here, and I would like to put this under the microscope. I have not tried that yet. I've never eaten this before, and I don't know really how to process this. So what I'm going to do is I'm going to open it. You see it's packaged, and I'm going to try to cut it as well and put it under the microscope, and I have no idea what to expect. So maybe we're able to see something interesting. Maybe it's going to be a total disaster and we're not going to see anything at all. Well, that's part of the whole thing here. Okay, yeah, we're just going to find out how this actually works. Okay, so this is dried meat with it says here what, with sea salt. So I'm also going to try to put this under the microtome. Okay, so but let's get started here first. I would like to show you what I got here. And some of you might have already seen them before from different videos that I made. And I'm going to start here with this small one over here. This is a homemade version of a microtome. Well, first of all, those of you who don't know that yet, microtomes are there to make very, very thin cuts of tissue. Okay, so that we can actually put it on a microscope slide. We need a very, very thin cross sections, and what you do is you put the specimen in here, and then you turn it, and then you use a knife, a sharp knife, for example, something like this here. Yeah, it looks a little bit corroded, but I will also use a razor blade, and then we can actually cut it across. Okay, and then we advance the specimen by turning it a little bit. Okay, then it's being pushed out, and then I can make another cut, and then I hopefully have very more or less or very consistent cross sections which you can put under the microscope. And this here is a homemade version. You see that essentially I put a little screw in here. There's a little it's called a nut and a bolt. Some washers to make it more stable. I used hot glue, a glue gun to glue it on. And that's it. And as a matter of fact, it does work. Okay, it's not very stable. Okay, it's a little bit wobbly, as you can see here, but it does its job, and actually I'm getting better cuts than just trying it without this. Okay, so this is essentially the first one that I've made, and then I've got a few others here as well. And every now and then, when I see that there is a question in the chat, then you please do allow me to interrupt myself a little bit, and then I would like to have a look at those. Yeah. So, and there are some questions might be a little bit off topic, but as long as they're microscopy related, I'm going to attempt to answer those. Okay, so there's already a first question here. Why did most of my expensive professionally prepared zoology slides, which I bought from reputable laboratory, not come with abbreviations of the type of sections that the specimens are? So like, for example, WM like whole mount, or CS for cross section, or LS for longitudinal section. I think this is what you mean. And I have to tell you, I don't know why they did not include that, but I have to tell you there's a general criticism. I don't know if it's a criticism really, but let's put it positively. I have a general advice for microscope slide manufacturers, and that is please, why do you not include better documentation? So sometimes you can buy the slide, it says maybe a whole mount or a cross section, and then you put it under the microscope. Yeah, but where's the learning effect if I don't actually know what I'm looking at? Okay, like the arrangement of cells, maybe, or any specific things to look for. That would be very educational if there were some kind of a, I don't know. I've even once proposed maybe put a QR code on the slide, and then when you take a picture of the QR code, then you're connected to a website where you get more information. I mean, that would be actually a very good idea. Yeah. So this is something where I generally feel that readily prepared microscope slides, I think they need a little bit of documentation, right? There's another question here. Do you store your microscope optics in a special humidity controlled environment? I'm probably overly cautious, and I try to keep it around 55 humidity at all times. The short answer is, and that's an important question really. So basically, how should you store your microscopes? I do not store them in a humidity controlled environment because in the place where I'm living, it's not necessary. Okay, I'm living in Central Europe, so it's different than in the tropics. And in the tropics, where the humidity is almost 100% all the time, and quite moist there, you indeed have the problems over the long-term use that some microscopes actually might start to grow some fungi on the microscope optics. And the problem apparently is so big that some microscope manufacturers even coat the optics with antifungal coatings so that the fungal growth is reduced. So I'm just saying that while I don't have to store it in a humidity control environment, I can understand that this might be necessary in some places. Okay, so this is just something that I would say. So, but let's go on a little bit here. This here is a 3D printed one. I downloaded the files, and I've got a 3D printer. And you can see here that the platform is actually, it should be a large washer or glass plate, and I didn't have that. So I put a small one here. And this is a 3D printed one. And simply it looks like this here. And as you can see that there is a screw in here that can be turned. And there is a little piston in here, also 3D printed, that's kind of pushed out. Yeah, I don't know if, I don't even know if I'm able to get it out completely. There's a little plastic, 3D printed. I can't get it out, but you get the idea. Okay, so there is the reason why this is in there, so that it doesn't turn with the screw. This also works. A little bit more of a proof of concept, really, but both of them have a problem, and I'm going to show you another one which has the same problem. And this is actually the highest quality microtome that I have. It's very, it turns very smoothly here. Okay, I added this paper and tape because there's a clamp goes around it. I did not want to damage and scratch it, so I'll just show you. It came with a very nice clamp, table clamp as well. Okay, I think I should just show you here. I just show you here. So this goes in here. Yeah. Can I even get it in there? Okay. Oh no, I can't get it in. Yeah, here we go. Yeah, it goes in here. Okay, and then I can tighten it, and then I can mount it on the table. Very stable, very solid. It wasn't even that expensive, I think. Yeah, but it also has a problem. Okay, not a problem really, but a slight disadvantage why I'm not using it. And this is that essentially the specimen is just is not stable in here. There is no clamp on the inside. Yeah. So if you put something in here, then yeah, it's not clamped in, so it can be lifted out very easily. And this is a problem, especially if you want to make very reproducible cross sections. Yeah. So in that sense, this nice microscope suffers the same problems as this one over here, as this one over here, because there is no inside clamp. And now I'm going to show you the one that does have a clamp, but which is actually of lower quality, but it actually still works better than some of those others. And that is this one over here. And you see over here that there is this tiny clamp, plastic clamp, which you can move by turning the screw here on the side. And look what happens. Yeah, when I turn it, yeah, you see that the screw goes in and it presses this plastic clamp inwards, and then the specimen can be held in place better, right? But I say it's slightly of a lower quality. Look, the glass plate is just in here. Yeah, so if this breaks, then yeah, I have a problem. Because making something like this is not going to be so easy. But it did come with a second one, a spare one. So if it does break, I still have a second one. Yeah, but at least it can be taken out. It can be cleaned easily. But one has to be a little bit careful that it doesn't break. And here, that's what can be turned, and this kind of pushes there's a whole piston in here outwards. But yeah, as you can see, it is a bit wobbly. Okay, maybe you can hear it. Yeah. Let me hear him next to the microphone. Yeah. In comparison to this one over here, this one is not wobbly at all. This is really, yeah, really smooth. Yeah. So for this reason, actually, if I have to make microtome cuts, I've always been using this one over here simply because of the clamp. Yeah. So if it doesn't have a clamp, how does this even work? And there is this little piston in here, and I think the way that it is intended is as follows, that you can maybe make some specifically animal tissues that are embedded in paraffin or wax, and it can be molten to the piston. So it actually is stable if you're using paraffin, if you're embedding the specimen in paraffin. Yeah? And it even came with a little cylinder here, and I don't know what this was for, but I can imagine that maybe that this is the mold for actually making paraffin. So you kind of have the specimen in paraffin, and then maybe you just kind of like a cookie cutter, you kind of stamp it out, and then you melt it maybe on here, yeah, and then it's also solid in here, and you don't need a clamp. Okay, I think that's the idea. Okay, so I'm going to quickly look again some of the questions that some of you might have. Okay. Does that mean that I need to keep my objectives in a humidity chamber or something? It's rain season here now, but do I need that? Well, honestly, the question again is with the humidity. I think, how would you do that in a humidity chamber? I would say the following. Try to avoid, if you're especially in the tropics or so, try to avoid large temperature changes. So sometimes there are air conditions, okay, and those air conditions do have the advantage that they remove the moisture from the air, so that's good. But it also means that the optics and the microscope and everything cools down. And then when the air condition is off and warm air and humid air starts to come in again into the room, then the humidity will condense on the colder surfaces. Yeah. So what I probably would, and then you have water there, right? Then it's really humid. So what I probably would say is maybe somebody please correct me, but maybe it would be maybe it's not so necessary to keep it in a humidity chamber or moist or a dry chamber. How would you do that? But rather make sure that the temperature is reasonably constantly low. And if you're using air conditioning, just make sure that it kind of cools down the room constantly, and that you don't have temperature changes, right? Is the hole on the side of the big white microtome, the hole on the side of the big white microtome? I don't now, yeah, I don't understand now. The hole, I mean, the thing is yeah, it's kind of held like this here, and this is the screw that kind of holds the clamp, yeah, of this one here. Yeah, it's a little bit hard to move out because I added this this paper tape around it to protect the actual microtome from scratches, because I think that's yeah, if you actually use something like this, it's gonna scratch the microtome, and I don't like that. Yeah, that's why I always add some kind of a protective thing around that. Yeah, yeah. So, but you can also see quite nicely one division is what 0.01 millimeter, so that's essentially 10 micrometers. Yeah, so if you're moving up yeah, one division, then essentially it's 10 micrometers, which is the thickness of a eukaryotic cell approximately. Maybe you could make a live stream where you're staining some plants, dehydrating samples, or just simply throw us some tips about staining. Now, the staining question has already appeared several times, and yeah, it's not always so easy to obtain stains, I have to tell you, because they don't like to send them. But yeah, I can make some staining. I'm currently in the process, because one of my students needs that, of making Carmino acetate staining, a Carmino acetate stain for how do you call this, chromosomes. Carmino acetate is used for chromosomes, and I'm currently making a stain. I actually wanted to buy a ready-made stain from a company, and the company then basically had high safety regulations and wanted yeah, the institute to sign a document that and it's complicated. So companies don't always want to send stains and chemicals. So what I'm gonna do now, look what I got here. I don't know, I've not tried some of those here yet. I'm just gonna try to make a couple of microtome cuts. Some of you might have already seen some of the videos where I use the carrot is easy to do. Yeah, this is from some kind of a cabbage. Yeah. No, not cabbage, cauliflower. It's called cauliflower. Yeah, this is some kind of a other plant, a mushroom. Well, I don't know. I'm just gonna try to make a couple of cross sections, and then we're gonna just see how this works. And yeah, a little bit of a side information. Every week I'm losing a little bit of sleep. No, I'm not losing some sleep, but it's not easy to come up with topics to talk about. And I said, well, maybe I should make another live stream using my centrifuge. And then actually my son said, oh, please no centrifuge, because I said, why not centrifuge? It's not interesting, it's boring. So I said, okay, why not why not do then one with the microtomes? But I also have this centrifuge one again on the agenda, because look what I got here. This is a centrifuged sample with some algae in here, and maybe at the end I'm also going to show it to you, just because I have it here. Yeah, excuse me. Look, those slides here, let's talk a little bit about slides as well, not just about microtomes. I like those slides because they're clean, okay, and they're ready to use. I do have other slides as well, which I show you, okay, which were significantly cheaper. But there's a reason sometimes why slides are cheap, but they are a disaster. I don't know if you're able to see that, but there's this white, completely white layer. It's kind of like water spots. I think it's calcium carbonate or something on here. It's completely useless. So if you have slides like this, what you have to do is you've got to wash them in vinegar, because the vinegar will remove the calcium carbonate. Just hold them up in yeah, maybe this, yeah, how, yeah, and this one here is so much, yeah, shinier, and this one is really clean. The other one it's not dirt really, but this is residue on it, which actually is also very difficult to remove. Usually I'm using some kind of a tissue paper, or you already know my, the microfiber cloth. Even with that, it's not possible to remove it. So you've got to treat it with some vinegar or some other weak acid. Okay, so this is basically yeah, one of the slides that I have to prepare. I've got also, of course, cover glasses. Yeah, look, everything's new. I don't know why they're vacuum packaging it. That's not necessary. Okay, but then again, yeah, who cares? And yeah, let's try to open this here. I better not spill those cover glasses. Yeah. So here we go. See, even they are nicely packaged in paper. Okay, I think I'm just gonna leave it like this here. We're gonna hope for the best that this actually works. Okay, how am I going to make a microtome cut? I'm going to use this one over here first because this is actually the easy one and the proven one to use. I do have this camera on the surface of the table. Let's move it a little bit like this. So, I'm not going to use this knife here. The reason is because I don't know how to sharpen it. I've not tried this before. I mean, I could sharpen it, but I need a wetting stone and these things. And as it is, no, it's too much too much work. So what I'm doing is I've 3D printed myself this little thing here, and this is the cover. This is essentially a holder for razor blades. Okay, so I like to use those fresh razor blades. They're pretty cheap, really, but also pretty dangerous, obviously. And yeah, what you need is you cannot use those razor blades as they are because they're too flexible. Okay, so I'm not able to pass them over like this, also because of course you're going to hurt yourself. So I found somewhere online a plan to make this here, and I 3D printed it, and it goes like this. And then how does this go? I think it's like this here. All you have to do is you have to press it together, and this basically yeah, not only protects it and gives it a little handle, but also prevents it from bending. And I've tried this a few times already. It is still a little bit flexible here in front, but actually it works quite well. I've also tried to use cutting board knives, and cutting board knives are not sharp enough. Okay, so actually this seems to work quite well. Okay, and then you have a protective little cover over here. Yeah, so yeah, I quickly check again if there's anyone here. No comments so far. Okay, and yeah, there are no comments, and the live stream is still working, so that's good. Yeah, I always have to check because last time I continued to talk, and actually the live stream was already interrupted. I don't know which one to start off with. I'm gonna try this cauliflower one here. And I'm going to put it in here, and then I'm going to see how this works. And the first thing that you have to do is I have to somehow cut it a little bit into shape. Okay, a little bit into because I have to be able to fit it in there, right? Again, this one honestly I have not tried yet. Okay, this specimen. You do not want it to yeah, touch the sides too much, otherwise there's going to be too much friction and it's not able to move out properly. Yeah? And of course, what I would like to see is I hope to be able to see the vascular bundles of this plant. Okay, the vascular bundles are those parts where water and nutrients are transported. The first thing that you have to do is you have to kind of lower the whole thing. Okay, yeah, so it's kind of moving down, as you can see. Yeah. Then I put it in, okay, like this. I close, I don't know, maybe I should go a little bit with the shape here. I don't know. Yeah, let's try it like this. Okay, so I clamp it in. It's reasonably stable. Okay, and the next thing that I need to do is I need to prepare a little dish with water, because the cross sections, let me put all of the other vegetables away for right now, because the cross sections are so thin that they dry out relatively quickly. So what I want to do is I want to immediately place it into some water. So because I don't have any running water where I am right now, I just use this here. Okay, okay. Some tweezers also are always useful to pick up the sample. Let's give it a try. Okay. Yeah. When cutting, make sure that you don't cut like this. Okay. So there should be the guide on both sides. So the knife should be, or the blade should be resting on the left and on the right side, and not like this. Yeah. It should not be suspended. Yeah. And then I don't know. Let's go. I have to also move it a little bit. See, and it's a little bit too thick. I see, but that's the first cut. And then, yeah, sometimes because of the flexibility of the blade, it's not completely flush with the surface. Okay, so that's a little bit the problem here as well. And maybe it is a little bit too big. Yeah, and then I turn it a little bit. I test it again. Yeah, and you see that it was a little bit too low. Yeah, so I have to turn it again. So usually I'm trying this with trial and error. Yeah, I'm just scraping the surface here. Yep. Still, yeah. We can try to pick it off and see if this actually, yeah, maybe not quite. Yeah. Usually when you put it in here, it starts to spread a little bit better. Okay. Maybe this is still a little bit too big. Yes. Okay, I don't know if you're able to see this properly, but yeah. And again here, as so often, it's pretty thin, as so often, it's a little bit again a question of trial and error, okay? Yeah, so the more often you try this, then yeah, you have a Gaussian distribution curve. This means some are going to be thinner, some are going to be thicker, okay? Yeah, so this one over here again seems to work quite nicely. Okay, let's put it in here. And then maybe 1, 2, 3. Okay, yeah, that was maybe a little too little, not high enough. It's still connected here. Yeah, so 1, 2, 3, 4. Okay, here we go again. Yeah. So making these cuts without a microtome is yeah, a little bit difficult. Okay, it requires more trial and error. So yeah, I've got them now floating in here, and let's try. Okay, so I'm going to simply transfer. By the way, by putting it into water, also some of the cell components, because some of the cells are going to be cut open, will be washed out, and sometimes this gives a little bit of a nicer and a cleaner, yeah, specimen. Yeah. So I'm going to put this on here. I'm going to try the other one here as well. It might be a little bit thinner, and I have to somehow spread this. Yeah, this is actually thinner than the other one. The third one maybe as well. This is difficult, of course. Yeah, because it likes to get it folds over. So if this happens, maybe I'm going to put it back in again here, and then somehow the surface tension of the water kind of makes it yeah, difficult. You know what I'm going to do? It's already a little bit messed up. Okay, so a little bit more water maybe. I don't know, is this pipette clean? I've used it yesterday to also pick up some pond water. So let's here, and I'm just going to try. Actually, could have used some larger cover glasses as well. Those cover glasses are reasonably clean. Okay, so let's try this here. You see that it's kind of thick, and the other one. And here. This looks a little bit thinner, okay, and everything goes under the microscope. But yeah, I think you can get a better cut by giving the blade a slight sideways motion while cutting instead of going straight. Yes, that is correct. So the idea is the following, but I have to make this. I've been going across like this. By giving it a slight sideways motion, it might be possible. The problem, and I think that's a little bit the problem, that this is a little too large. I'm a little bit afraid that I might actually not have enough space, yeah, because the blade is not long enough. Yeah? So that's maybe I should make this a little bit smaller, right? Aren't those pipettes disposable? Yes, they are. But if I'm just using regular water, I'm just recycling them because there is no reason for me to throw them away. Let's just quickly see. I'm switching over to the microscope view now. I'm just saying that the thing, it's laggy. Very laggy. I don't know why. I had this already some time ago. The camera does not respond very quickly. For those of you, see, it's horrible. I already had this before. What I'm going to try to do is I'm going to quickly try to deactivate and activate it again, because yes, now it works better. Okay, so this is now the 40 times. Why don't you see just a second, the stage? Does this work or not? Unfortunately, the stage, I hope that I'm able to get the stage camera to work as well, but it doesn't. All you see is this white circle. Okay, yeah, so I'm just going to tell you, this is now the 4 times objective, and let's go up a little bit. This is now the 10 times objective, and generally I have to tell you, I'm kind of happy with this. Okay, individual, you can, by focusing, you can actually see how many cell layers thick it is. Okay, and here again, yeah, maybe I have to close down a little bit. Yeah, now for those of you interested, I've basically connected the camera over HDMI. So my camera out has an HDMI connector, and then I'm converting the HDMI signal to a USB signal. So I've got this not so expensive converter, and that's basically how this cauliflower looks like. And this here we go. These are the vascular bundles that I was talking about. Okay, those vascular bundles, these are cells that are transporting water. The xylem transports water up the plant, and the phloem transports it down. And yeah, you're able to see those vascular bundles scattered throughout the leaf. Okay. Yeah, there's a comment here. I have one of those HDMI to USB-C converters too. Yeah. I have also connected my camera some time ago directly over USB. The company Canon, it's a Canon camera that I have, has its own driver where you're capable of using the DSLR camera just like a webcam. So this also works, but yeah, I simply connected it over over HDMI now. Yeah, yeah. So that's basically it just shows that I think that this seems to work quite nice. Have you ever heard about gum damar as a substitute for cannabalism, a mounting medium? I'm about to make some. I've heard about it, but never used it. Yeah, so I know that gum arabic has also been used in some mounting media, and maybe even as an additive. But yeah, gum damar. I don't know if it's not a water-based mounting medium. Okay. Canada balsam has apparently the advantage, I've never used it myself, has the advantage that it has apparently an extremely long-term stability, but it has the disadvantage that the sample must be completely dehydrated. So this basically means you have to work also with organic solvents, first in alcohol to remove the water, and then you have to work with xylene to remove the alcohol again. So Canada balsam apparently, even though I never used it, has the huge advantage of being very long-term stable, but apparently specimen preparation is not so easy. So that's why for quick mounting and also for educational use, sometimes water-based mounting media might be an advantage. Yeah, but actually, look, if I focus here, maybe 2 cell layers thick. Maybe I got it 2 cell layers thick. Yeah, so yeah, it's quite okay, I think. This is now bright field. Okay, that's basically bright field. Yeah. Can you explain a bit what we're seeing? I see blue and brown shapes. Okay. Yeah. So this is I've got an arrow somewhere. That's actually a good point, because I automatically assume that people know everything about plant anatomy. So what I've got here is I've got an arrow. Where's the arrow? Does this arrow work? No. Now it should work. Okay, yeah, here we go. Right. So what you see over here, those little round circles here, these are the individual cells, of course. And the outside of the cell, this is the cell wall. Plant cells have a cell wall, of course. And back in the day, the early microscopists were very, very interested in the plant cell wall because it's so easily visible. And at that time even, I read, there was a debate going on. They were wondering, what is now the living part of the cell? Is it the inside that's alive, which we cannot see here? Because when I cut it open, it got flushed out. Or is the cell wall the living part of the cell? So there was actually a debate going on. There were actually some people who were saying that essentially a plant is like a sponge, so to say, where the wall is the living part, and in the middle these are basically just the holes, so to say, right? But now, of course, we know that the cell wall is just the outside and the living part is the inside. Okay, so we see a whole bunch of cells here, and the question is now is what are these things? These are the so-called the vascular bundles. And those, let me maybe find a different one. And yeah, here, big ones, right? And those vascular bundles, if you look carefully, they too are made of individual cells. And if you look carefully, then you can see that the cells in here, they have a thicker cell wall. So I suppose that this here would be the so-called xylem, which transports the water up the plant. And in many plants, the xylem is also reinforced and has thicker cell walls for stability purposes. So those cells are not only important for transporting water, but also for giving stability to the plant. Yeah? So this basically, these are the so-called the vascular bundles, right? And they're essentially responsible for transporting substances. Yeah. So, and yeah, there's some people who are commenting that it's possible to stain them using various stains. But yeah, I'm digressing now, because actually I said that this live stream should be about microtomes. Okay, now I'm talking more about the plants. So let's go back a little bit again to the desk view, and I don't know, what I could do now is I could try to cut a carrot using this one over here, with all of its advantages and disadvantages, because there is no clamp. Okay, maybe either a carrot or a potato, or maybe the mushroom. Mushrooms are, I think, not so interesting, but we're also able to see the cells here. So let's try this. And here, of course, because there is no clamp, okay, I have to somehow make sure that the stability in the side of the microtome provides stability. Otherwise, otherwise it's kind of floating around too much. So what I'm going to do is going to, I don't know, maybe this is not the best idea here. I'm going to use the potato. I'm going to show you why. Okay, I'm going to show you why. So I'm going to cut the potato like this. And now I'm going to use this thing here, which was provided. It's a little bit, has this a little bit sharper edge here. And look what I'm doing right now. And I don't know if this actually works, but I'm going to, okay, here we go. So, here we go. And here is the potato. Let's push it out. And let's turn this down. All the way down. Maybe not all the way, but a little bit more down. And now I'm able to insert this in here. And let's try it like that. Okay. So, all the ingredients for vegetable soup. That's correct. Okay. So let's try it like this. Okay. Again, here we have the issue a little bit that this might not be. Look, this is now a problem, right? It's not. How do you say? Long enough. So maybe I do have to use this knife here. Okay, and now I can actually go across and slide it across. Very nice. Okay. And ooh, look, do you see this here? Look. Aha. See, that's actually already shows you the disadvantage. Yeah, it was lifted out. Yeah, and now essentially, it's flush on here, and now it goes in. So that is essentially the problem with this here, right? There is no clamp. So maybe, I don't know. Yeah, how maybe somehow hold it in here, I don't know, without cutting myself. Okay, now it's flush. So let's try it again. Yeah, let's rotate this a little bit out. Yeah, and let's try it again. Very thick, and because I lifted my finger, yeah, it's too thick on the side here, right? Yeah, it's quite, I guess, yeah, it's okay over here, but still not satisfactory. Yeah, but I think you get the idea a little bit, the problem, yeah, that I'm having here. Yeah. So what I'm gonna try now, see, I have to lift it out that far until it becomes flush here on the side. It's that, yeah. So what I'm gonna try now is I'm going to try like this. Maybe this is gonna work better. Okay, but as you can see, it's a little bit of a problem because, yeah. So here we go. Now it's flush again. Let's rotate it out. But I do have an idea. Yeah, it's too much. Okay. Do have maybe yeah, if I just cut it a little bit like this here, very lightly, and like this. Difficult. And that's why, because of this issue, I've never used this microtome very often. Yeah. Again, I've got this one here in here, but I think it's still a little bit thick. Yeah. Yeah. So let's try it again. Yeah, this is a little bit better. Okay. The potato is quite, yeah, here I think it's quite thin. Yeah, so make sure that it's not going up too much. Yes. Yep, I think I'm just going to try it and see how this works. Yeah, this one is also quite thin. Yeah. So actually it looks quite okay. Yeah. So I'm going to try to put this under the microscope and we should be able to see a couple of starch grains. Yeah. Let me have a look. There is some question. Let me just quickly, vegetable soup. There's actually quite an elegant solution using the ring to fit the specimen to size. Yeah, that's the thing here. Someone suggested the side holes are to pin the specimen down, the side holes. The question is which ones? Okay. So it could be maybe the holes in the piston. Huh? And what is the hole on the side for? Which hole on the side? Maybe, are you talking about this one over here? This hole on the side, I think, is a small screw that actually holds the black plate in place. If this is what you actually are referring to. There's one over here, there's one over here, and there's one over here. And there's a wrench. I think you can go in here, and this will actually hold the plate, this black plate. Okay. Yeah, so that's a little bit the thing. So unfortunately, it's not for holding the specimen itself. Yeah? So I need some slides. Let's have a look. Where is the next slide? Here we go. And this is way too big, right? So what I'm going to do is I'm going to do it the easy way. And I think it's still a little bit thick, I have to tell you. This one is too thick. I'm just going to use the other one in here, yeah, which has a very thin part here. Up, or I can't see what where I'm cutting. Okay, so this should be it. Let's have a look here. So just drop it on here. Seems to be okay. So I'm going to switch over again to the microscope. And I don't see any, I'm kind of wondering why. See, that's interesting. It's again responding extremely slowly. So what I'm going to do again is I don't know what the problem is here. I'm going to deactivate it again and activate it again, and hoping that, yes, now it's interesting. Now it actually does respond again quickly. So let's have a look whether this actually works. Ooh, yes, actually I'm quite happy. But let's turn the arrow off because I don't like the arrow. Yep, and we actually see starch grains inside the cells. Or at least most of them should be inside the cells. Look, quite nice. Here on the side, as where the specimen becomes thinner, okay, actually where the specimen stops, you can see that these starch grains are not surrounded by a cell wall because they have been washed out. Yeah. So, and over here, this is where the specimen starts. I have to focus again. You can see the round starch grains of the potato, yeah, inside the cells. Yeah. You need iodine. Yes, I have iodine, but I will tell you the following. I do have iodine, but I'm not going to use it because I am afraid. The iodine that I have is, iodine is very aggressive. So if you actually spill some of the iodine or get it into contact with a microscope optics, it actually will corrode. So what you can do, however, is you can stain it first and then wash everything in water to remove any excess iodine. So the iodine that goes into the starch will be bound, so that should not be a problem. But any excess iodine that might spill out from the behind the cover glass will then be removed. And that's actually something that I would recommend. Otherwise, if you have this concentrated iodine, and my solution that I have unfortunately or is very concentrated, it's not good for yeah, apparently it's even strong enough to corrode metals. Yeah. But I think you get the idea that yeah, this actually also quite works nice. I think switching scenes in whatever program you're using causes the HDMI feed to lag or to buffer. That's correct. I'm using OBS Studio, and for whatever reason, yeah, every time when I switch scenes, then it lags. It's actually a new. By the way, this is a new HDMI adapter that I have. The other HDMI adapter had another problem. It had always created static, yeah, and the flickering. And this one does not do that, but it creates a strange lag. Okay, yeah. So didn't know that. Well, I'm just saying, just make sure that if you use iodine, that just make sure that it does not get into contact with the optics, right? Otherwise, you can use it. I mean, iodine is a normal stain that is used in microscopy a lot, but especially at higher concentrations, I read it's quite corrosive, and yeah, one should take care that it doesn't yeah, stain anything. Yeah. Yeah, so they are beautiful using polarized. Yeah, I was using it by adding it to water. Yes, then you're diluting the iodine down, and then it's less of an issue, right? I was basically saying sometimes what you can do is, and that's something that I'm not doing, you could take the iodine and actually add it to the specimen while the slide is on the microscope stage. Yeah, so that is something that I would be a little bit more careful, okay? Because then if you are pressing a little bit too hard on the pipette, then you might get too much iodine out, and then you might actually get it also on your microscope optics and so on. So that's the thing that I was actually referring to. Yeah. So yeah, so this is essentially another example. I hope I did not forget any questions so far. Okay. Yeah, how do I scroll? It's interesting. Now I'm not able to scroll the chat anymore. Okay, kind of interesting. Okay, just a second. Here's the scroll bar again. Yeah, Oliver, what if you dilute the iodine with 5 parts of water? Yeah, you can do that, and that's what I'm also doing occasionally. Yeah, I basically dilute it down, and then I rinse everything again in water before I put it under the microscope. Yeah. Can you embed a small sample of something in potato or carrot and slice it? Yeah, that's actually something that I wanted to do anyway. I don't know if this is going to be so easy to do, but that's the reason why I'm going to show you. Thank you for reminding me. I just want to show you how you can actually use carrot, and that's actually why I have the carrot here, as a holder for thinner specimens. Okay. So I've got this here. This is from a vegetable, from soup. Yeah, and I would like to do the following now. I would like to take a small part of this here and put it under the microtome, but this is too small. I'm just going to cut it like this. Okay, just to show you. Okay, so here it's a little bit more fresh here. Okay, I'm just going to maybe cut it like this. Okay, maybe cut it like this. And let's say that I want to get a cross section of this here. Yeah, and this is way too thin, really, to put it. Yeah, where's this? Yeah, to put it in here. Yeah, it's not. You won't be able to properly clamp it down. So what you can do is you can use potato, or I prefer to use carrots, because the carrots, they don't have those starch grains that might contaminate the specimen. Yeah, you can use a carrot as a holder for this here, and that's what I like to show you. Okay, so again, let's put the vegetable soup away. Yeah, or actually I can't, because I need the carrot. Yeah, so let's do the following here. So let's save this here for later on. Here, this is the carrot. Okay, like this. I somehow have to cut it down a little bit to make it fit into the holder. Okay, so maybe that's gonna work. And then I make a slice, but I don't cut all. Oh, you cannot see that. Okay, I basically cut it maybe up to here. Yeah, and I keep it connected here. Okay, so that's the thing here. And then I will put it in here like this. Okay, so it's a little bit too large over here, so I might remove this. So so the carrot essentially has become now the holder for this thinner specimen. People in the past have used elderberry. It's a plant, and the inside of the stem also contains almost looks like styrofoam, and you can use that as well. However, styrofoam is not recommended to be used. I've tried it myself. And the reason is because styrofoam really is very, very bad for the edge of the knife. Okay, what happens is the following: is as you cut through styrofoam, the friction is so high that the very, very front part of the knife's edge starts to melt, and this causes the knife to become dull very quickly. Yeah, because it's really, we're talking on I think on an atomic level here, but styrofoam has a very high friction, and this causes on an atomic level the knife's edge to become dull, right? And for this reason, styrofoam is known to be very, very tough on knives, and therefore it should not be used. But I mean, then again, if you have a disposable knife, who cares really? Yeah. So let's try this again. So this is a little bit of a slightly experimental again for me. Am I able to fit it in here? Oh, no. Yes. Can I? Difficult. Okay, here we go. Yeah. I have to clamp it down again. Yeah, the problem with that again is if you clamp it down on the bottom, then the top part might sometimes comes apart a little bit. So let's give it a try. Let's try the razor blade again. If I happen to cut myself, then I'm going to put some blood under the microscope. So again, you see, that is a little bit the issue here, that I'm not able to cut all the way through here. Okay, so, and that is indeed a huge disadvantage. So maybe I am indeed going to use this knife over here. It does seem to be a little bit flush. So let me see a little bit. Yeah, it's not completely smooth. So let's try like this. Okay, I do have a slice here. Okay, which is still a little bit too thick, I think. I cannot believe this. Actually, did I pull it out? I think I pulled it out. Can this be possible? Ooh, okay. So here we have some demonstration problems. Yeah, it's gone. Here it is. Yeah, so let's try it again. I'm going to cut the side here to make it easier to be clamped down. Okay, so and let's give it another try. Yeah, these live streams are sometimes a little bit improvised. Okay. Okay. Yeah, see, that is the problem. Yeah, what do we learn from this here? I just want to show you that the friction of the knife always rips out the specimen. So what you have to do now in this case is the following. Take it out completely again. I have to raise everything here. Okay, so I'm going to raise everything. Yeah. And you see that also the clamp comes out further. Okay, so, and let's give it another try. Okay, so here again, let's clamp it down. Okay, I hope that this is now stable enough. If it's not deep enough, then yeah, it can be pushed out again. So let's try it. Ooh, bad. That's why it didn't work. Okay, so let's turn it out and let's try another one. Still too deep down. Here we go. Okay, we can try to put this now under the microscope. Yeah, hoping that it's able to be on the edge. So sometimes it flips over and then you're still only getting the top view. So here there is some separating paper. My table is a complete mess. That's okay. And here it is. We put it in here, hoping that it didn't tip over. Okay, so if not, then I'm going to try another one. Okay, here it is. Very thin. Yeah. And I put a cover glass on top. The problem is I don't have my reading glasses, so I cannot really see quite well in which direction it's lying. Okay, I might add more water. And let's give it a try again. Okay, so where is the microscope? Deactivate it, and I'm going to activate it again. And now I don't know why it's doing that. Yeah? So let's hope for the best. Is this a side view? It is the side view. Could it be? Here's the other one. Is this the side view? I hope it is. Okay. Yeah. But at least what we can see here is, there are still some some starch grains, maybe because from the knife. Okay. But I'm quite happy to be able to see that the cross section is fairly thin, that I'm able to see individual layers of cells. So let's zoom in a little bit more, turn up the light. And it's gone. How is that? Yeah, okay. Here we go again. So here we are. Okay. So we see that actually the cells, or the layer, the cut that I made, at least over here, it is fairly thin. So I'm quite satisfied with that. And over here it's a little bit thicker. Interesting. Yeah. And a couple of starch grains from my knife, because I was cutting potatoes before. So I'm going, yeah. So I'm going to go again a little bit. I hope I'm not dilute iodine. Yes, maybe you turn the micro too far. Maybe try very small steps without pressing your finger. Yep. How is the starch grains look in polarized light? The thing is I do have polarized light right now. However, I'm not using cross-polarized filters. Okay, so this is a little bit the thing. Yeah. I think if you scroll up, we can see the xylem. I don't know if this is the, yeah. But in any case, we can see the individual cell layers. But maybe if I go down with the magnification a little bit, then we get a better overview. Yeah. Then we can get a better overview here. What's this for long thingy here? I don't know. Okay. Yeah. So, some air bubbles. Okay. In any case, yeah, it does demonstrate that, yeah, I've done this very quickly. It does demonstrate that I'm able to make relatively thin cross sections this way. Yeah. Again, if you want to have better quality, you have to try this more often, but now, just for the sake of the live stream, I'm doing this quite quickly. Okay. Okay, so yeah, so let's have another look at something here. Where is the desk view again? Here we go. Yeah. So let me quickly check. So I'm not waiting. Maybe trying to 3D print that leaves a larger surface area for the blade exposed. Yeah. So the idea is the following: is to have maybe another 3D printer for the blade exposed. That would be actually possible. Yeah, I just have to then think a little bit of how I'm able to, I just show you how this works. Ooh, this is dangerous. Okay, because essentially the center of the blade is held by those two little things here. Up, so here we go, almost cut myself. Yeah, but that's basically how it looks like here. Those little holders here, and they go in here. Yeah, and but another thing that I have tried and which also worked is I've used disposable razors indeed, and instead of using a microtome, this is something that I could have tried as well. I just took the specimen, yeah, and simply shaved off, yeah, with the razor. This also worked. Okay, yeah, you also need a little bit of patience, but the pieces that you got were very small, but it's actually also possible that you can try to do that. Take a disposable razor and try to shave off some of the things here. Well, what else do I have? I mean, I've tried now everything. The mushroom. No, not the mushroom. The mushroom's not so interesting. I promised you to have a look at this here. Haha. Okay, and this is going to be another interesting one because I don't know if it's going to work or not. Okay, so please don't have too high expectations. Yeah, I'm going to simply, but before I do that, I will clean up the mess a little bit here. So all of the vegetables that I have here, I'm going to clean away, and I would like to put this what Nordic Elk jerky, as it's called. I'd like to put that under the microscope now, and again, I've not even opened it. I don't know how it's gonna work. I don't even know if I'm able to cut it properly. I know nothing. Yeah, I don't even know whether it's going to look good under the microscope or not. Yeah, so that's why it's highly experimental right now, and I don't even know how it looks inside because I've never, yeah, seen this myself. So let's try to not just rip it open carelessly, but let's try to open this carefully so that. Ah, okay. Okay, let's have a look. I just need one. Ah, here is one piece. It smells good. Ah, look. I think if you just look at this, if you just look at the fibers, if I am able to soak it in water, I think I'm not even going to cut it. I think it's difficult to be cut. I think what I'm going to try to do is I'm simply going to separate the fibers like that, hoping that then I'm able to see maybe the individual meat fibers. I wonder, am I able to cut this or not? I think this is going to be too difficult. So what I'm going to try to do is the following. I'm going to try a different thing here. I'm going to take a piece here, another piece here, and let's put this somewhere. Let's add a little bit of water. I don't know if I'm able to separate this, and maybe this way. It's still very, it's starting to become softer. My hope is because I've done this already with chicken meat some time ago, and I was able to actually look into the individual muscle cells. Yeah? I think this is way too large. Yeah? But maybe if I'm able to get some individual fibers here. Maybe you don't need a lot, really. It might also absorb some water over time. But that's one of the things that I like about microscopy or generally nature observation. Yeah, you don't know always what to expect. There's always a little bit of a surprise element involved. And yeah, I did it with boiled chicken meat, so that might be the trick. Maybe I should add some hot water to the whole thing here. Okay, let's put this in here. Has anyone ever put some Nordic elk jerky under the microscope, or is this the first in the history of humankind? I don't know. So let's macerate this. Yeah, I think what I'm gonna do is I'm gonna try actually boiling this. This might actually separate them. You know what? Just for this is not enough really. But I'm gonna give it a try anyway. Otherwise, you know, even if this doesn't look good or if there's nothing specifically interesting to see here, doesn't matter. I will try to optimize this a little bit, and then there will be a video about this, obviously. Okay, in this channel here. So let's switch over again to the microscope view, which again probably no, actually now it works. Now there is a rapid response, interestingly. So, and here it is. I can actually see the individual fibers. That's good. I'm hoping to be able to see the so-called the light and the dark bands. For those of again, look at again the starch grains. Okay. Yeah, here there's some individual fibers. Let's go a little bit higher with the magnification. More light. Now I lost it a little bit where it is. Here it is. Actually, it looks kind of nice, thinking about it. Yes, beautiful, beautiful, beautiful. Yes, I'm so happy. I have to explain what you're seeing. Okay, let's go up. Let's go up. I hope that the distance works. No, it doesn't work. Dang. And I lost it. Yes, here it is again. Here it is again. Okay, I'm going to explain to you now what I'm seeing here and why I'm so excited. So where is the arrow? It actually worked. I cannot believe this. Sometimes, where is the arrow? Here is the arrow. Look at this. Look at this cell over here. And I hope that you're able to see this on YouTube. I'm using now my 20 times objective. I cannot go higher because it's so thick that I'm actually going to bump into the microscope slide. But are you able to see the striations? It looks like striped. Okay. Yeah, it looks like there are tiny little stripes next to each other. These are the so-called the light and the dark bands of so-called striated muscle, skeletal muscle. Yeah, and that is very typical for skeletal muscles. And if you're able to see these striations, and then you've got a pretty good microscope, because they're pretty small. Yeah. Yeah, and I'm very happy that I'm able to see them here, because this cell over here is actually separate from the others. Here it's overlapping, but here those tiny little striations, yeah, and they appear because of the protein fibers actin and myosin, where they're overlapping, and then the protein fibers are able to slide past each other, contracting the muscle. Yeah, and so that's the thing that I was actually hoping to be able to show you. I know that I'm getting excited about this, but yeah. So I'm gonna check again. I'm going to check again some of the comments here. Yeah. Somebody told me to wash the blade in ethanol between the two cuts. What's the benefit of this? Good question. I don't know. I mean, if you wash the blade in ethanol, the ethanol is going to evaporate quickly, so it's going to be dry. Yeah. So I don't know. I don't know if this has an advantage, because sometimes if the blade is a little bit moist, then this actually will help in cutting, right? Or maybe the ethanol does help in cutting a little bit. Yeah. Most likely it was already answered, but I just came back. What lighting are you using to view the samples? DIC. This is basically DIC, but DIC does use polarized light. But I'm not using cross-polarized filters, right? So that's why you see the background, the blue is blue. This here is now regular bright field. So these are now the natural colors. Yeah. I can close a little bit the field diaphragm. Okay. Yeah. So these are basically the natural colors. You can still see the striations, and yeah, this is basically a DIC, which is a little more colorful. Yeah. So, okay, at least I was able to show you that. Are these the sarcomere stripes? Yes, exactly. So these are basically the light and the dark bands of the sarcomere, and the sarcomeres are the contractile units of skeletal muscle. Okay, so that's basically, I was hoping to be able to see that, and yeah, I was able to show it to you. It's a little bit of a how do you say, an add-on. Yeah, actually, I was thinking about cutting the meat, under the microtome, but actually, this is probably not gonna work quite well. And if I were to cut it across like this, then I'm not able to see the striations, because they're running longitudinally. Yeah. So what I'm gonna do now with this piece here, it smells good. No, I'm not gonna eat it. I think I'm going to soak it in water overnight, and maybe I'm able to prepare a somewhat nicer slide. And because this actually works now, there will be a video, a regular video, like, I don't know. But let's say Nordic Elk under the microscope or something like that, I'll call it. Okay, yeah. But I've been talking over an hour again, 1 hour 12 minutes, and I think it's slowly time to call it a day again. Hope you liked it. In any case, those video sessions, live streams are always a little bit improvised, as you can see. It also keeps it interesting for me. Well, I'm going to call it quits now. I hope you liked the video. Do consider subscribing to the channel if you haven't already done so. Also, please do watch my other videos that I am uploading. Ever since I started uploading some YouTube shorts, there have been less views on my regular long-form videos, interestingly. But I'd like to, of course, we'll continue making those as well. Yeah, hope that these videos also kind of keep you motivated in trying to observe things yourself. And I'm going to call it a day again. I wish you all the best. Happy microbe hunting, and hope to see you again next week. Bye bye.